Hello, and welcome to Knowledge to Fall Asleep To. Tonight, we're not leaving for distant galaxies. We're staying right here, on the only world we've ever called home, to wander through Earth's quiet miracles. Not the loud kind, the gentle kind, the kind you can feel more than you can explain. Life is everywhere, in forms so strange they sound invented. It glows softly in the deep ocean like drifting constellations. It clings to stone in deserts so dry they seem allergic to breath. It rides invisible on the air you inhale as if the sky itself has a living pulse. Some creatures have existed for hundreds of millions of years with hardly a change, as though time passed them by with polite respect. Others survive in places so brutal they feel impossible. And yet, there they are. Each one a small wonder, all holding a fragment of the larger tapestry that connects us all. If you enjoy these slow journeys, you can gently tap like, subscribe, or share your favorite fact in the comments below. It helps other sleepy minds find their way here. But for now, you don't need to do anything at all. Just rest. Breathe softly. Listen closely. Let your thoughts loosen their grip as the stories of life begin to unfold. Let's begin. Life on Earth may have started in the deep, far beneath sunlight, at hydrothermal vents on the ocean floor. When we imagine the origin of life, we often picture warm ponds under a gentle sun. But many scientists believe the first chapter may have been written in darkness, under crushing pressure, where strange chimney-like towers exhale mineral-rich water from the planet's interior. It sounds harsh, and yet it's almost nurturing. Minerals there can act like catalysts, helping simple molecules link together into more complex forms. Tiny mineral pockets may have served as Earth's first laboratories, sheltered cradles where fragile beginnings could assemble, protected from the chaos of the early world. And even today, these vents are crowded with life that doesn't need sunlight at all. Creatures drawing energy straight from Earth's chemistry. It's moving to think that our shared story may have begun not with warmth and light, but with heat, pressure, and shadow. Some living things can survive being frozen solid. Imagine becoming ice, heart stilled, blood unmoving, then waking as if nothing happened. For certain organisms, that's not fantasy, it's strategy. Some North American frogs, like the wood frog, can let much of their body freeze during winter. Their heartbeat stops, their circulation pauses, and still they do not die. Their bodies flood tissues with special chemicals like glucose that act as natural antifreeze, protecting delicate cells from the bursting. When spring arrives and the ice releases its grip, they thaw, rise, and hop away as if the season never tried to erase them. Some insects and small invertebrates have mastered similar tricks, surviving freezes that would end most other lives. These adaptations remind us that life isn't merely fragile, it's inventive. It finds ways to endure even in stillness, like Earth itself built a pause button into the script and quietly taught its creatures how to use it. And not all ecosystems need the sun. We're taught to think of sunlight as the ultimate source of life. Plants drink light. Animals eat plants. The chain loops endlessly. But in the deepest ocean, where light never reaches, entire worlds still thrive in total darkness. Around hydrothermal vents, blind crabs, giant tube worms, and ghostly fish gather in abundance. Their foundation is not photosynthesis, but chemosynthesis, where bacteria harvest energy from chemicals like hydrogen sulfide rising from the vent fluids. Those bacteria become the base of a thriving food web that survives without a single photon. Deep underground caves hold other communities that live similarly removed from day. In many of these species, eyes shrink or vanish, while touch and scent grow sharper, turning darkness into a navigable landscape. It turns out life doesn't need light the way we thought it did. Sometimes it builds its own world in the dark. Some other glowing sharks use their light the way we use words. In the black water, where distance disappears, they communicate. They signal to a mate. They warn a rival. They announce without sound that something alive is approaching. The glow comes from specialized organs called photophores, scattered across their bodies like constellations pinned to moving flesh. In the ocean's twilight zone, these sharks drift like swimming stars. And once you imagine a predator that carries its own soft lantern into the abyss, the sea stops feeling like an empty darkness. It becomes a hidden theater of light, where even hunters must shine in order to survive. Greenland sharks can live for more than 400 years. In the freezing North Atlantic, one of Earth's strangest giants moves slowly through deep water. Many are partially blind, their eyes clouded by parasitic copepods. Yet their lifespan is almost unbelievable. By using radiocarbon dating on the proteins in their eye lenses, scientists have found individuals older than 4 centuries, making them the longest-lived vertebrates we know. Some of these sharks were already alive before Shakespeare wrote his plays, before telescopes opened the sky, before empires rose and fell in the way we now remember them. They grow at a pace so patient it feels unreal, sometimes less than a centimeter per year, and may not reach maturity until they are over 100. Cold, darkness, and slowness seem to stretch time itself around them, reminding us that life does not experience the clock the same way across this planet. Some fish can survive for weeks without oxygen. For most animals, oxygen loss means a fast ending. But in ponds and rivers, sealed under winter ice, where oxygen drops to nearly nothing, certain fish reveal a different kind of endurance. Goldfish and their wild relatives, like crucian carp, can switch their metabolism into an emergency mode. Instead of producing deadly lactic acid the way humans do when starved of air, they convert it into ethanol, essentially alcohol, and release it harmlessly into the surrounding water. It is a biochemical escape hatch, letting them endure long, suffocating winters and wake again when spring returns. It is not comfort, it is survival. While we would gasp after minutes, these fish endure silence for weeks, proving that when the environment demands it, life can bend its own rules. Lungfish can sleep inside mud for years. When drought turns rivers into cracked clay, most fish die. But lungfish, ancient living fossils with both gills and lungs, just have learned another strategy. They wait. As the water vanishes, the lungfish burrows into the mud and secretes a coating of mucus that hardens into a protective cocoon. Inside that shell, its metabolism slows to a whisper. It breathes through its lungs in tiny, steady sips, holding on for months, sometimes even years, until rain returns and the river rises. Then it breaks free and swims as if time never happened. This is estivation, a kind of summer sleep, and it is not about fighting the drought. It is about becoming still enough to outlast it. Some eels migrate thousands of kilometers to reproduce. For centuries, Their life cycle was a mystery. Even Aristotle wondered where eels came from, because no one could find proof of their breeding. Today, we know they perform one of the most astonishing migrations on Earth. European and American eels spend decades growing in rivers and lakes. Then, driven by an ancient clock, they begin an epic journey across the Atlantic to the Sargasso Sea, a region of floating seaweed. There, in the open ocean, they spawn and die. Their offspring, tiny transparent larvae shaped like leaves, drift on currents for months and years, transforming along the way until they return as young eels to rivers their parents will never see again. It is a cycle so vast and elusive that even now, scientists still struggle to observe it in full. Parrotfish sleep inside a mucus cocoon. Beneath coral reefs, when night arrives, parrotfish do not simply wedge themselves into a crevice. They build a bed. They secrete a layer of mucus that forms a clear protective bubble around their bodies, and masking their scent from predators like moray eels and helping shield them from parasites. Watching one resting inside its shimmering cocoon feels unreal, like seeing a creature wrapped in a thin ghost veil. At dawn, it breaks out and spends the day grinding coral with a beak-like jaw, creating the sand that becomes tropical beaches. Every night, the ritual repeats, a fragile barrier against the dangers of darkness. A reminder that in the wild, even sleep is never simple. It is an act of survival. Seahorses reproduce through the male. In the underwater world of seahorses, the usual roles flip. After delicate courtship dances, the female deposits eggs into a specialized pouch on the male. He fertilizes them, supplies oxygen and nutrients, and carries them as they develop. Weeks later, he goes into labor and gives birth to fully formed miniature seahorses that burst into the sea. This strange design allows the female to produce more eggs while the male takes on the burden of pregnancy. To witness a male seahorse giving birth, twisting as dozens of tiny lives erupt into water, is both surreal and oddly moving. Nature does not obey our expectations, it rewrites them. Some insects can walk on water. Water striders glide across ponds as if skating on glass. Their secret is physics. Microscopic hairs on their legs repel water and trap a thin layer of air, preventing them from breaking the surface tension. With each step, they press down on the rippling skin of the pond and use it like an invisible trampoline. Sometimes whole groups move together, synchronized like dancers on a reflective stage. For them, the boundary between air and water is not a wall, it is a playground. Tardigrades can survive lethal radiation. These tiny creatures, often called water bears, are among the toughest forms of life we know. They can survive the vacuum of space, and they can withstand radiation levels thousands of times higher than what would kill a human. They do it by producing proteins that help protect their DNA, and by entering a near-death state where they dry out and their metabolism falls almost to zero. Years later, a single drop of water can bring them back. Scientists study them in hopes of learning how resilience might translate into better radiation protection, medical applications, or long space travel. The water bear reminds us that strength is not size, it is endurance. Some algae can live inside rocks, in extreme deserts, where sunlight burns and winds dry the surface into something almost unlivable. Life still finds shelter. Certain algae live within the pores of rocks, protected by translucent minerals that filter the harshest conditions. They survive on faint light, seeping through stone and tiny traces of moisture, creeping along micro cracks. Scientists have found them in Antarctica's dry valleys and in Chile's Atacama, places so severe they are used as models for Mars. These hidden algae expand our imagination of where life can exist and what other worlds might hold. Lichens are a partnership, not a single organism. What looks like simple crust on rock or bark is actually a symbiosis. A fungus provides structure, shelter, and minerals. An alga, or sometimes cyanobacteria, performs photosynthesis and supplies energy. Together, they form a living union greater than either part alone. Lichens can colonize bare stone, ice, rooftops, and deserts, slowly breaking surfaces down and preparing the way for other life. Some may live for thousands of years. Their quiet persistence teaches a deep lesson. Survival is not always competition. Sometimes it is cooperation. Some bacteria breathe metal instead of oxygen. For most life, oxygen is the final electron acceptor in respiration. But in environments where oxygen never reaches, deep mud, caves, groundwater, some bacteria use metals instead. Iron, manganese, even uranium can play the role oxygen usually plays, and the bacteria transform these elements as part of their metabolism. They can leave rusty films on rocks or change metals into new chemical states, quietly reshaping the world around them. Their existence echoes an ancient Earth when oxygen was scarce, and it hints at possible life on alien worlds where oxygen is absent. Some microbes can break down plastic. Plastic, one of humanity's most persistent inventions, spreads into oceans and soils and resists decay for centuries. Yet even this synthetic material is not completely immune to life. Scientists have discovered microbes that can break down certain plastics and use them as an energy source. A well-known example is the bacterium Ideonella sicaiensis, which produces enzymes that degrade PT, the plastic used in many bottles and packaging. Some fungi have also shown plastic degrading abilities in laboratory conditions. The process is slow and imperfect, but the message is striking. In only decades, life has begun adapting to a substance that never existed in nature before. Forests communicate through underground fungal networks. Beneath the forest floor, fungal threads weave through soil and link tree roots into vast networks. Through these connections, trees can share nutrients like carbon, nitrogen, and phosphorus. They can also send chemical signals, warning neighbors about insects or drought. Older trees, sometimes called mother trees, may support seedlings through these underground pathways. Scientists often describe this as a kind of forest-wide web, a silent communication system that turns a forest into a community rather than isolated individuals. Once you know this, walking through woods feels different. Each trunk becomes a tower, connected by invisible lines. Plants can release airborne chemicals to warn nearby plants. Even rooted and immobile, plants are not passive. When insects chew their leaves, some plants release volatile compounds into the air. Neighboring plants detect these signals and begin preparing defenses, producing bitter chemicals, toughening tissues, or even attracting predators that hunt the insects. To us, these warnings are invisible, carried as faint scents we might never notice. But across fields and forests, alarm messages drift on the wind. Plants do not merely endure fate, they participate in survival. Venus flytraps can count. The flytrap is a predator made of green. It does not waste energy on false alarms. Inside each trap are tiny trigger hairs. A single touch is ignored. But if a second touch happens within about 20 seconds, the trap snaps shut. In a real sense, The plant is counting. Further movement stimulated to release digestive enzymes, turning the insect into nutrients. It is a precise strategy, built without nerves or a brain, a reminder that intelligence can appear in forms that do not look like ours. Some plants can remember. Memory is usually associated with animals, yet certain plants show a kind of learning. In experiments, sensitive mimosa plants which fold their leaves when touched were repeatedly dropped in a harmless way. At first, they closed defensively. Over time, they stopped responding, as if they learned the stimulus was not dangerous. Weeks later, they still behaved as if they remembered, ignoring harmless triggers while reacting to new threats. This memory is not stored in neurons, but in biochemical changes that alter future responses. Plants may be rooted, but they are not unaware. In their own way, they record experience. Bamboo can grow nearly a meter in a day. Under ideal conditions, some bamboo species shoot upward at breathtaking speed. Their hollow, segmented stems allow efficient transport of water and nutrients, fueling rapid growth. For centuries, bamboo has been crucial to humans as food, shelter, tools, and instruments. Its speed also makes it a symbol of resilience and renewal. Unlike forests that take decades to mature, bamboo can be harvested and rebound within a season. Its growth is not just fast. It feels like nature showing what happens when design meets patience. Titan arum produces one of the world's largest flowers. In the rainforests of Sumatra, an extraordinary plant sometimes rises like a tower. When Titan arum blooms, which is rare, its inflorescence can reach over 3 meters. It opens to reveal a deep red interior and releases a stench like rotting meat, drawing beetles and flies that pollinate it while searching for food. For a brief window, it becomes both beautiful and grotesque, a living spectacle. Botanical gardens often draw crowds when one blooms, because the moment is short, dramatic, and unforgettable. Some orchids deceive insects by mimicking females. Certain orchids have evolved to lure male insects by imitating the appearance and scent of females. Their petals resemble insect bodies, and their surface chemicals mimic pheromones. Males attempt to mate with the flower, and in doing so they pick up pollen and carry it to the next orchid, completing the plant's reproduction. It is evolution by illusion, not force, but persuasion. Corpse flowers smell like decay to attract pollinators. Few natural experiences are as intense as standing near a blooming corpse flower. Native to Sumatra, it can produce a powerful odor detectable from far away. To humans, it smells like decomposition. To carrion flies, it is irresistible. They crawl deep into the flower and transport pollen between blooms. By mimicking death, the plant secures its own continuation. In its strange beauty is a reminder that survival wears many masks, and even disgust can be turned into a tool of life. Some seeds can remain dormant for thousands of years. Seeds are time capsules. Wrapped in protective coats, they hold the blueprint of future life and wait. Scientists have revived plants from seeds preserved in Siberian permafrost for tens of thousands of years. And they have germinated ancient date palm seeds around 2,000 years old found in the Judean desert. This endurance comes from a remarkable ability to almost stop metabolism, protecting fragile tissues from time. Holding such a seed is like holding patience made physical. Mangroves can filter salt from seawater. Along tropical coasts where sea meets land, mangrove forests rise with tangled roots like living nets. They thrive where most plants cannot, in salty, brackish water. Some species filter salt at the roots, pulling up mostly fresh water. Others excrete salt through specialized glands on their leaves, leaving white crusts behind. Their roots stabilize shorelines, provide nurseries for fish and crabs, and protect coasts from storms and erosion. Mangroves show that survival in harsh environments often comes not from resisting, but from adapting with quiet strength. Watching a grassland rise again after fire, you witness raw vitality in motion. It's proof that ruin and renewal are not enemies, but two beats in the same natural rhythm, destruction making room, rebirth filling the silence. Coral reefs, those vast underwater cities we imagine packed with fish, turtles, and impossible color, are built by some of the ocean's tiniest architects. Soft corals are small animals, distant relatives of jellyfish. Each polyp releases calcium carbonate, laying down a hard skeleton grain by grain till thousands of years become a living fortress. Alone, a single polyp is fragile. Together, they create structures so immense they can be seen from space. And these reefs are not decoration. They are shelter for roughly a quarter of all marine life, offering food, hiding places, and nurseries for new generations. They soften the odor of waves and storms, acting like living seawalls that guard coastlines. Without coral, tropical seas would grow quiet and barren. Their work is almost invisible up close, yet it sustains entire kingdoms of beauty and diversity. To swim through a reef is to pass through a cathedral not made of stone, but of breath and bone, built by countless small bodies cooperating across centuries. In that radiant maze, the clownfish finds refuge inside the venomous arms of a sea anemone, a sanctuary deadly to most. The anemone's stinging cells can paralyze intruders, but the clownfish wears a special mucus shield, letting it rest safely in danger's embrace. In return, the fish defends its host, clears debris, and stirs the water, so the anemone can breathe. It's a fragile treaty between protection and peril, held together by mutual trust. Elsewhere on the reef, cleaner fish run something like a clinic. Larger fish, even predators, gather peacefully at cleaning stations and wait their turn. The cleaners pick off parasites, dead skin, and scraps, sometimes even swimming into open mouths to scrub gills. What looks like a spa is actually survival through cooperation, a moment where neutrality thrives in a world built for competition. Some sharks never truly stop moving. For them, swimming is not just travel, it is breathing. Certain species must keep gliding forward to push oxygen-rich water over their gills. To sleep, they dim parts of the brain while the body continues its endless motion, half dreaming in perpetual drift. The ocean becomes both road and home, life sustained by momentum that cannot pause. Sea turtles begin their first desperate journey by reading the sky. On warm beaches, hatchlings burst from the sand and crawl toward the brightest horizon, guided by moonlight and starlight shimmering on waves. That ancient navigation system has led them for millions of years. As adults, they cross entire oceans and somehow return to the very beaches where they were born. A precision still partly mysterious, shaped by Earth's magnetic field and celestial cues. Their voyage reminds us that even the smallest light can lead a life through immense darkness. In the icy seas, penguins can drink salt water safely. Above their eyes are special glands that filter salt from the blood. After swallowing seawater or salty fish, they excrete concentrated brine, are dripping from the beak or sneezed out in a fine spray. A quiet miracle of biology, turning the ocean itself into a limitless drinking source wrapped beneath a tuxedo of feathers built for ice and surf. Some birds sleep while they fly, over endless ocean where land is too far and stopping is impossible. Species like great frigate birds can glide for weeks. Researchers have found that they can switch off half the brain at a time, letting one side rest while the other stays alert enough to steer. The naps are only seconds long, but repeated again and again, they add up to survival. It's dreaming in motion, resting without surrendering the sky. Albatrosses take that mastery even further, riding wind with almost no effort. With wings spanning up to 3.5 meters, they use dynamic soaring, and climbing and dipping in huge arcs to harvest energy from invisible air currents above the waves. They can travel tens of thousands of kilometers a year, sleep on the wing, sip rainwater, and touch land, mainly to breed. Watching one drift over the sea is like seeing a creature stitched directly into the atmosphere, as if the sky itself is an endless highway. Hummingbirds carry fire in miniature. Their wings move so fast the eye can barely follow, letting them hover, reverse, and dart like living sparks. To fuel that flight, their hearts can beat over 1,000 times per minute. Their metabolism burning so fast they must drink nectar almost constantly, visiting hundreds of flowers a day. At night, they enter torpor, slowing the heart dramatically, a brief winter inside a single body. Tiny as a coin, but yet capable of crossing the Gulf of Mexico in one non-stop flight, they prove how fierce life can be when it chooses speed. In other corners of the world, courtship becomes performance art. Birds of paradise clear a stage, then dance, sway, and unfurl feathers into symmetrical living kaleidoscopes. Females watch with exacting attention, judging precision and creativity. Elsewhere, grebes run across the water in synchronized ritual, moving like mirrored music. These displays are not mere instinct. They are evolution polished into theater, survival expressed through beauty and rhythm. Deep in Australian forests, the lyrebird becomes a composer of the modern world. It can mimic almost any sound it hears. Other birds, rustling branches, camera shutters, and even chainsaws or car alarms. Males weave these borrowed noises into elaborate songs to impress females, blending nature and machine into one strange symphony. Standing in the bush and hearing the forest echo back as imitation is unsettling and mesmerizing, as if wilderness has learned to speak with a city's voice. And then there is the Arctic tern, chasing daylight across the planet. Each year, it travels from Arctic breeding grounds to the Antarctic and back, a round trip that can exceed 70,000 kilometers, tasting 2 summers in a single year. Over a lifetime, one bird may fly distances comparable to multiple trips to the moon and return. Fragile in appearance, yet defined by motion, it turns migration into a kind of cosmic dance, a life written directly onto the map of Earth. Some spiders take to the air without wings, using silk like a parachute. A newly hatched spiderlings climb to a high point, lift their bodies, and release threads that catch the wind. They drift across fields, forests, sometimes even out over the ocean. Some have been found thousands of meters up, riding unseen among clouds. Others land on ships far from shore, having crossed vast water on invisible currents. The sky isn't empty. It's full of travelers too small to notice, carried by threads thinner than thought. Orb weaver spiders, meanwhile, craft silk stronger than steel by weight. Their webs shimmer in morning dew like geometry made alive. Different silks serve different purposes: strong radial lines, sticky spirals, soft wrapping threads. Though delicate to the touch, these webs can hold insects far larger than the spider itself. And scientists have long tried to replicate spider silk for medicine and engineering, but its complexity still resists easy copying. Night after night, a small body completes what our most advanced machines still struggle to manufacture. Trapdoor spiders build hidden homes underground, burrows lined with silk, sealed with a camouflaged hinged door made from soil and plant matter, the hinge itself woven from silk. Inside, the spider waits motionless, reading vibrations like a language. When prey approaches, the door snaps open, the spider strikes, and the entrance closes again as if nothing happened. A fortress designed for secrecy, a world of hinges, darkness, and sudden violence happening inches beneath your feet. Some parasitic wasps take horror to a biological level, turning other insects into unwilling puppets. They inject eggs into caterpillars or cockroaches, and as larvae grow inside, they release chemicals that alter the host's behavior. A cockroach may be led like a sleepwalking marionette into a burrow, becoming living food for the next generation. It sounds like science fiction, but it is evolution's dark genius, efficiency so ruthless it rewrites the victim from the inside out. Inside a beehive, survival becomes choreography. Honeybees share information through the waggle dance, a looping movement that encodes direction and distance to food relative to the sun. Others watch, decode the pattern, and fly straight to the flowers described. It's a moving language, flexible enough to adjust as the sun shifts, turning thousands of individuals into one coordinated intelligence. In their dance lives both necessity and beauty, a message written by evolution and performed in every buzzing city of wax. In rainforest shadows, some frogs carry their young like precious cargo. Strawberry poison dart frog fathers, for example, transport tadpoles one by one on their backs, climbing from the forest floor to high plants. They place each tadpole into tiny pools held by leaves or bromeliads. Mothers may return to feed them unfertilized eggs, a quiet sacrifice that keeps the young alive. It is care rarely seen in amphibians, survival expressed as patience and devotion. Then nature reveals births that feel almost unreal. The Suriname toad's back becomes a nursery. After mating, the female's skin softens and the male presses fertilized eggs into it. The skin grows over them, sealing each into a honeycomb-like pocket. Weeks later, fully formed tiny toads emerge directly from her back, popping out like living beads. It may look unsettling, but it protects the young and raises survival odds. What seems strange to us is simply a solution written into an ancient lineage. Glass frogs take transparency to an eerie elegance. In cloud forests, their skin and muscle can be see-through, especially the belly, revealing a beating heart, coiled intestines, even developing eggs. This invisibility may help them avoid predators by blending into the leaf-lit glow of the canopy. Seeing one feels like looking through a living window, the fragility of life exposed, yet perfectly protected by a thin veil of glass. In North American deserts, horned lizards defend themselves in a shocking way by shooting blood from the corners of their eyes. The blood tastes foul to predators and can spray surprisingly far. It's not effortless. The lizard must build pressure, and it may become briefly disoriented, but it works. Not always graceful, but effective, proof that nature's strategies can be strange and brutally practical. The basilisk lizard, nicknamed the Jesus lizard, seems to break physics by running across water. With powerful hind legs and specialized scales, it slaps the surface to create air pockets, moving fast enough to avoid sinking for several meters before diving. Juveniles can run farther than adults, but even large individuals can sprint quickly to escape. It isn't magic, it's physics exploited by evolution. Yet, in the jungle's glittering light, it looks like myth made real. And above the rainforests of Southeast Asia, even snakes can glide. As paradise tree snakes flatten their bodies and launch from branches, undulating mid-air to steer, turning ribs into a living parachute and generating lift. They can travel over 20 meters in a single leap, a ribbon of motion where you expect gravity to win. Scientists study their flight to understand aerodynamics, still amazed at how something wingless can be so controlled. Komodo dragons carry ancient predatory power in modern flesh. For decades, people thought their danger came mainly from teeth and bacteria, but research has revealed venom glands too. Their venom can reduce blood clotting and blood pressure, contributing to shock. A single bite can doom large prey like deer or water buffalo, even if it escapes at first. The dragon follows the scent trail, patient as a relic from a harsher world. Crocodiles survive by mastering stillness. As with slow metabolisms, they can go weeks or months without food. They can also slow their heart rate to only a few beats per minute, conserving oxygen and energy while motionless in water or mud. This lets them ambush with almost endless patience and endure long scarcity that would starve other predators. Their steady, ancient heartbeat is a reminder that survival is not always speed. Sometimes it is efficiency, silence, and the ability to wait. In murky waters where vision fails, some fish speak in electricity. Electric fish like knifefish and elephant nosefish generate weak electric fields, sensing objects, navigating in darkness, and exchanging coded pulses that identify rivals and companions. For humans, electricity is technology. For them, it is a natural sense, as ordinary as sight. Electric eels, though not true eels but knifefish relatives, can deliver shocks strong enough to knock down a person, historically even enough to stun a horse. Their bodies function like living batteries, stacks of specialized cells that discharge together in a powerful pulse. They also use weaker pulses to sense their environment. In the Amazon, they've long inspired both fear and respect. Biology transformed into lightning. In the twilight of the deep, light becomes weapon and shield. Many deep-sea fish don't glow on their own. They host bioluminescent bacteria in specialized organs. The bacteria provide steady light, and the fish provide shelter and nutrients. Some use the glow for camouflage, blending with faint light from above so predators below can't spot their silhouette. Others use it as bait, luring prey toward a waiting mouth. Even in darkness, life finds a way to shine. Squid turn their skin into speech. Beneath the surface, chromatophores, tiny pigment sacs, expand and contract in an instant, creating flashing patterns across the body. Scientists believe many species use these shifts not only for camouflage but for communication, coordinated stripes and pulses that may signal courtship, warning, or teamwork. A school of squid can look like a living light show, conversations written in color that we can't fully translate. The vampire squid, despite its ominous name, is less a hunter and more a patient scavenger. It lives in oxygen minimum zones where most creatures would suffocate. Gelatinous and slow, it conserves energy, drifting through near-dead water and collecting marine snow, sticky organic debris, rolling it into food. Its dark, cloak-like webbing and eerie form earn the name, but its strategy is gentleness and thrift. It proves that survival does not always mean strength. Sometimes it means endurance, efficiency, and the art of living on almost nothing. Deep near Antarctica, the colossal squid remains one of the ocean's most elusive giants. Rarely seen, it carries one staggering feature: the largest eyes known in the animal kingdom, up to around 30 centimeters across, like dinner plates. Those massive eyes help detect faint light and the shadows of predators such as sperm whales. To imagine staring into them is to feel the abyss looking back, the ocean's vast darkness made visible in a single organ. Some deep-sea fish look like they were designed by a dream. The barrel-eye fish has a transparent, dome-like head, a living glass helmet that reveals its eyes inside. Those eyes often point upward to spot prey silhouetted above and can rotate forward when needed. The clear shield protects the eyes from stinging siphonophores. In the deep, the skull becomes a window, and the rules of form rewrite themselves for survival. And then there is the anglerfish, a nightmare made practical. In eternal darkness, the female carries a glowing lure on a stalk above her mouth, lit by bioluminescent bacteria. Curious fish and squid drift closer, and in an instant the jaws snap shut, swallowing prey nearly half her size. In some species, tiny males fuse permanently to the female, becoming little more than living attachments that provide sperm. It feels like fiction, yet it is simply what existence demands in the deep. Down there, light is life. And the anglerfish turns hope into a trap. Beneath the waves, camouflage becomes an art form. Decorator crabs pluck pieces of sponge, coral, even living sea anemones, and hook them into tiny hairs on their shells like jewelry. Their moving gardens blur the outline of their bodies and let them disappear into the reef. Some choices are tactical as well as beautiful. Anemones can sting would-be predators, sponges can ooze toxins, and in return, the crab carries them to new hunting grounds. Watching one shuffle across the seafloor is like seeing a fragment of reef stand up and walk away. It looks whimsical, but it is strategy, a quiet pact between body and landscape. Hermit crabs solve a different problem with equal ingenuity. They do not grow their own shells. They borrow abandoned ones. When a promising, oversized shell appears, a crowd gathers. The crabs line up from smallest to largest, each waiting for the one ahead to move into the new house so it can claim the freshly vacated one. In a few moments, a whole chain of upgrades ripples down the line. Competition turns into choreography, and a shortage of shelter is eased by patience and order. Other creatures rewrite the very way reality looks and feels. Mantis shrimp, blazing with color, carry not 3 but up to 16 kinds of color receptors, seeing ultraviolet and polarized light that are invisible to us. To them, a coral reef is not just bright, it is encoded with secret signals and hidden patterns. The same animal wields one of the fastest strikes in the animal kingdom, hammer-like limbs whipping forward so quickly they create tiny collapsing bubbles that flash with heat and light. A single blow can crack shells or even aquarium glass. They are jewel-bright engineers of physics, fusing extreme perception with explosive power. Far from the sun, life becomes stranger still. Green glowing worms trace ghostly lines in the dark ocean. On the seafloor, black smokers and hydrothermal vents build chimneys of metal sulfides, and around them whole communities survive without sunlight at all, living on chemistry instead of light. In boiling hot springs, in lakes so acidic they can strip metal deep in the rock miles below our feet. Microbes endure pressures, temperatures, and toxins that would kill us in moments. They feed on hydrogen, sulfur, and stone, painting pools in impossible reds and yellows and quietly filling the deep crust with unseen life. These extremophiles stretch our idea of what habitable means and whisper that if life can thrive here, it might also endure in the frozen oceans of Europa or the hydrocarbon lakes of Titan. And above all this, evolution tells its longer story. The sparrow on a fence and the hawk circling the sky are not just related to dinosaurs. They are dinosaurs, feathered descendants of hunters like Velociraptor, still carrying hollow bones and clawed feet. Crocodiles basking on a riverbank are living fossils, barely changed in more than 200 million years, because their design was already good enough. Lungfish, with both gills and primitive lungs, bridge water and land, echoing the first steps of vertebrates onto shore. Whales, the giants of the sea, all began as wolf-like mammals walking ancient coastlines before their limbs stretched into flippers and their nostrils slid to the tops of their heads. To see a whale surface is to watch a land animal that turned back to the ocean long ago, singing a story of departure, return, and transformation written into bone and tide. Long before stallions thundered across open plains, their ancestors were no bigger than a small dog. About 55 million years ago, a creature called Eohippus, the dawn horse, crept through ancient forests on several small toes, browsing soft leaves instead of grazing on tough grass. As climate shifted and woods gave way to wide grasslands, horses grew larger, their many toes fused into a single hoof built for speed, and their diet changed with the land beneath their feet. Every gallop you see today carries the memory of that journey, from shy forest dweller to powerful runner of the open world. In the sea, evolution wrote an opposite story of scale. The blue whale is the largest animal that has ever lived on Earth, dwarfing even the biggest dinosaurs. Stretching over 30 meters and weighing around 200 tons, it moves through the water with surprising grace, feeding on tiny krill by the millions in a single gulp. Its heart is the size of a small car. Its low calls can travel across entire ocean basins. Sharing a planet with such a giant is a reminder that life's imagination is far larger than our own. Insects tell a quieter tale of endurance. Silverfish, dragonflies, and cockroaches appear in ancient fossils looking almost identical to their modern descendants. 300 million years ago, our dragonflies with wingspans wider than a human arm glided over primeval swamps. Their bodies have shrunk, but their basic design has barely changed. Cockroaches, so often despised, have survived multiple mass extinctions with only minor edits. Their success shows that evolution is not always about constant change. Sometimes the greatest achievement is creating a form so effective it can simply persist. Earth itself has nearly been reset again and again. At least 5 times, mass extinctions have swept away most species, from the Permian catastrophe that wiped out over 90% of life, to the asteroid impact that ended the age of dinosaurs. Each time, ecosystems collapsed, and yet life returned. New forms radiated into the empty spaces, strange and beautiful in ways no one could have predicted. Without those disasters, mammals might never have flourished, and humans might never have appeared. These events reveal both how fragile and how stubborn life can be, a fire that dies back only to roar up in a new direction. Even at the frozen ends of the world, the past lingers. Today, Antarctica is a desert of ice, yet deep in its frozen soils lie remains of ancient forests, ferns, conifers, and other trees that once flourished in a milder age. Preserved seeds, spores, and plant fragments still hold fragments of DNA, molecular memories of those vanished green landscapes. Holding such a fossil in your hand is like holding a tiny bottle that contains a message from a world long gone. Proof that even the coldest continent once bloomed inside your own body. History is written in another language, hidden in our DNA, are fragments of ancient viruses, the remnants of infections that struck our ancestors millions of years ago. These endogenous retroviruses make up almost 8% of the human genome. Most are silent now, but some have been repurposed. One viral gene helps build the placenta, making mammal pregnancy possible. The invaders became collaborators. Our genome is not a clean blueprint, but a patchwork survival story, stitching old battles into new abilities. With every breath, you join a different kind of story. The air you inhale is full of atoms that have cycled through countless other beings. The carbon you exhale might once have been part of a leaf, a bird, or a dinosaur's bone. The oxygen you draw in may have flowed through the lungs of mammoths or whales. Atoms are endlessly recycled, passed from organism to organism like beads on an invisible necklace. Breathing is not just staying alive. It is sharing matter with forests, oceans, and creatures that are long extinct. Beneath all of this lies one shared script. From bacteria clinging to volcanic vents to oak trees, hummingbirds, and humans, almost all life on Earth uses the same genetic code. DNA's four-letter alphabet writes the instructions for every cell, changing only in sequence, not in language. The recipe for a mushroom and the recipe for a whale are written in the same chemical handwriting. This unity tells us that everything living is related, branching from a single ancient ancestor. The tree of life is vast, but its roots meet at one point, and all of it, including you, is built from star remnants. Long before Earth formed, massive stars forged elements like carbon, oxygen, iron, and calcium in their blazing cores. When those stars exploded as supernovae, they scattered their heavy atoms into space. Over time, that dust gathered into new stars, planets, oceans, and in the end, living cells. The calcium in your bones, the iron in your blood, the oxygen you breathe were all created in those stellar fires. You are literally made of stardust, a small part of the universe that woke up and began to notice itself. And now, dear listener, our quiet journey through the wonders of life comes to a gentle close. Together, we have wandered through forests and oceans, deserts and ice, across deep time and hidden worlds. We have followed tiny ancestors and towering giants, glowing worms and singing whales, and watched life fall, rise, and reinvent itself again and again. If your eyes feel heavy, you can let them close. Let your breathing settle into an easy rhythm. shall like waves on a shore, wings beating in the distance, or the slow pulse of a blue whale far below. With every breath, remember that you are woven into the same tapestry, one thread in Earth's long, unbroken story. If this journey has stirred your curiosity or calmed your mind, you are welcome to like the video, subscribe, or leave a comment when you wake. It helps this little channel keep telling these quiet, wondrous stories to the world. But for now, there is nothing else you need to do. You belong to this planet, to its ancient rhythm, to its great and gentle mystery. Let that thought cradle you, the way the sea cradles its creatures and the earth holds all life close. Sleep well, dream of stars and oceans, and remember, you carry their story inside you. Good night.